Most important question when discussing infinite series. Is it what type they are? How large they get? What do all these random symbols that Math Sensei keeps on drawing on the screen even mean? Well, all of those are wrong. And the real answer is one simple question. If I add up all the terms in an infinite series, do they converge to some finite value or diverge to infinity? And today, I'll show you how to get the answer to that question. So, without further ado, let's move on to the video. Now, in this video, I will be showing you a bunch of tests designed to test whether a series converges or diverges. So, let's start with the first test, the divergence test. Now, the divergence test is if I take an infinite series and have the nth term be f of n, as you have the limit as n approaches infinity of the nth term, and we see whether this equals 0 or not. If it does not equal 0, it automatically diverges and you can stop there and you already determined that it's diverged. But if it's equal to 0, the test is inconclusive. Now, you might be like, but if the term goes to 0, then since all the terms are getting smaller, it surely should converge. But what also matters is how fast those terms get smaller and reduce to 0. One example is the harmonic series. As I covered in my last video, the harmonic series diverges. But if you look at the test, it passes this test. So there is another reason behind that, and it also shows that not every series that passes this test will converge. So that's test 1. What about the second test? Well, really, we will be talking about 2 tests, because these 2 tests both have to do with forms of infinite series. One of them is the p-series test. Now, in my last video, I talked about p-series, and p-series is 1 by n to the sum power of p. Now, if p the magnitude of p is greater than 1, then the test converges. If p is less than or equal to 1, the test diverges. And this again is a test that would say that n is equal to 0 to infinity, 1 by the harmonic series, 1 by n, since by the p-series test, this would diverge. So that's the p-series test. Now let's talk about the geometric series test. Now, as you all know, a geometric series is n is equal to 0 to infinity, a times r to the n. Now, if the absolute value of r is, again, less than 1, then that means that it converges. And that's how you do the test. And it's pretty much that simple. Now, what would be the sum of this series? Well, the sum of the series would be a over 1 minus r. So, this small thing about geometric series is incredibly important, as it outlines whether it converges, and if it does, what the sum is. Now, there is one final major test that I want to talk about, the ratio test. Now, the ratio test says, alright, let's take the limit of the n plus 1 term over the nth term. Now, if this test is less than 1, if this test becomes less than 1, so if limit is less than 1, it converges. If it's greater than 1, it diverges. Now, these are just a few tests that are planned over here. There are many more tests, and those tests will be revealed in other videos. So that is about it for this video today. Thank you so much for watching this video. I'll see you in the next one, and bye-bye.